So we're going to save our playground. I'm going to go to my afternoon's playgrounds, just like we've been using already. And I'm going to give this playground name. I'm going to call this objects and methods. And so it's inside my playgrounds folder, just like we've been using. And as you just hit create on there, we're good to go. Notes description, notes today. There we go. Notes today equals quotes and using Swift to make classes and methods. There. So again, using the idea that we can actually keep track of what we're working on, having a descriptor of that inside our actual documentation. Always a nice thing. We've got that saved, ready to go. And so within Swift, because the playgrounds allows us to actually keep track of that, we can actually make the playground right here represent that class. So we're going to make this really simple. We're going to go public, and then class, and then the name of class we'll call this simple class. And right here at this point, we have an existence of simple class. We have our class completely defined right here. It's as stupid as stupid project number 1. Okay, doesn't do anything, has no information. We're going to go ahead and add to that though. We're going to add a data member to it. So we'll have a private var, and let's call it, and it's of type string. And so this demonstrates the basic structure of how a data member should be declared. And as you can see right now, I have a giant error showing on my screen. This is bad. Oh no, I have to fix this. So I have the error indicator happening right here at this lovely red stop sign right here. A red stop sign right here, plus the giant big red stop sign right here saying it has no initializers. So as soon as I have a data member, it reminds me I must explicitly initialize those data members inside my Swift code. So this won't compile. If I look down here at my error message, I have an error. Class simple class has no initializers, product class simple class, and then because I have this var name string, that stored property without initial values prevents synthesized initializers, it can't compile. So I can't do anything until I handle this first. So the way I'm going to handle that is I'm going to create the init. And so again, with the init, it's a visibility, in this case public, and then the keyword init, parens, followed by a set of squiggles. And to assign a value in Swift, I can do the default value right here. I'm going to say name equals quotes, and my name is. And as you can see right now, my lovely red X disappeared from right here, and the line of code on the name of the declaration for that in the declaration section. All those errors disappeared. I now have that handled. It's taken care of. So my object does exist. So we have that init right here. Everything's taken care of. We're good. Great time to do what? Commit. Yes, save and commit. Okay, so save. Go over here to my GitHub desktop application. Go to my lovely afternoon's playground. Oh, there I am. And look, I've got my lovely new playground listed right here, which is inside my objects and methods.playground file. And so I added a sample class. Again, we want to make sure we give a definition of what we're doing to the commit message, making sure it makes sense. Commit to master. So I'm back inside my simple class. This simple class doesn't do very much. So let's check and see how visibility works inside Swift or access control. And so I'm going to go right here. I'm going to go to line 16 and write print. I'm going to say that I'm going to get an instance of simple class first. So var sample equals, and then simple class, parens. That declares an instance of type simple class. If on your screen you have a underscore LLDB underscore some number dot simple class. Sweet. That is this your guys' version of Xcode's way of handling it, just on the demo side. It's not an error message. It's just there. It's okay. So if I want to try and print this, so if I print and say sample, parens, I go out right there, you can see that underscore LLDB that I was just talking about. So that's the internal representation in memory of that class, and the .simple class to say what it is. Okay, sweet. That's just the playground's method of handling that instance right there. This is almost as useful as printing an object in Java if we don't write a toString. Those numbers are just like, hey, you made an object. Woot! Var sample2 equals simple class parens. Even though sample2 and sample1 are different values, they're different variables, they're different things. It's like, hey, I'm printing it. It's just going to print the memory location it's stuck at, name of the class. Hooray. Not exactly the most useful thing on the planet. Now, what I want to do, though, is I want to actually see the visibility on this. So I'm just going to delete those lines 18 and 19 because they're not very helpful yet. And I'm going to go sample.name. So I'm going to go inside the class and look at its internal state. And oh no, name is inaccessible due to private protection level. Uh-oh, I can't look inside an object outside of the class. Oh, because private is in here, that means I can only see the variable name when I'm inside the squiggles of lines 8 to 15. Anywhere after that, no dice. Can't touch it, it's unavailable. So if I look at this lovely message right here inside this, note name is declared here on private var name, and it's inaccessible to a private protection level. So the way I fix this, I could just make it public, but that's inappropriate. We want to have our data be private and have it be publicly available only when we need it. So again, we add a method. And we've already done this before. Let's add a method to this. So I'm going to go ahead and delete this line right here, line 17, just so I get rid of the error message, because we don't like errors. I'm going to go inside my class. I'm going to write public, and then func for the keyword for function, and then get name. And it's going to return a type string and return name. So now I have, in addition to my lovely class, I added a method to the class. As you can see, just like with Java, when I add a function inside a class, I have to declare a visibility for it. It needs a return type declared for it. It's just organized a little bit differently. And so public, the func keyword, the name of the method, which should reflect what it's doing, followed by the assign or the returns operator, and then the return type that it gives us back. Inside the actual squiggles for the method, we define what it's going to give us back, in this case, the variable name. So if I go print parens, and now sample.getName parens, I will print my answer. My name is ... And so we have that right there. So we have a visible action that I can access my private data. So just like with Swift, just like with general rules of personal conduct, private data does not belong outside. Private data is for inside the object, in this case name. Name exists inside here. I have this reference name right here that if I highlight on it, you can see it highlights across the board all the same values that it's referring to. And I can get access to it only by having a public modifier on a visible method. If I were to make this method be private, crash, burn, and again, getName is declared here. It's inaccessible because it's private. Oh, oops. Question, Aaron. You are the only person writing code right now, but your code could be given to another group or programmer for doing some external access. And so some things you'll want to make it so they are public so that other people can change them. And so that you'd make a getter like this. Other times you may not actually ever need to be, you may not ever need to make an externally visible value. And so it can be only needed to be accessed on the inside. And so we'll be talking about that as we get more with the design. But yeah, for right now, it's not that big of a deal. As we get to bigger projects, that's where it makes a bigger difference. So changing the visibility on that makes it go private. And again, the question was, why do we make these things private if we're the only ones changing them? And right now, we're the only person changing them. But as our projects get bigger, again, who our code is seen by and what that code has access to will change. So we'll talk about this more as we go further through our development cycle. But for right now, it's just we're doing the good practice so that when we do bigger projects, we're ready to follow the right practice for that. Okay? So we have that basic structure right here. Let's take this a step further and add to this. So we're going to go ahead and add another class to our sample playground right here. And so it's going to be public, and then class, again, because the keyword class indicates it's a class. We'll call it other class. I know, amazing name. Followed by our great friend, the squiggles. We're going to give two data members this time. And so we have a private var favorite number is of type int, and a private var favorite word is of type string. Now, because this public class, other class, has those two data members, I have an error message right here that says, oh, look, it has no initializers. I have to fix that. We're going to use the ability to make multiple initializers for this next piece, though, so we can see the two different ways of handling that, and also talk about some of the differences between Java and Swift. So we're going to go ahead and make a new init. This first init will be a default init. So public init, and then parens, followed by squigs. And in this case, I'm going to say that favorite number equals int parens, and favorite word, equals string parens. With this, we have our default init. The default init is going to assign the default init of int and string each to the associated data members of that type. So we have a base value assigned to them automatically. But then we're going to make a better init, one that we can use so we can, if we want to have specific values. And so we're going to go for public init, and then parens followed by favorite number is of type int, comma, favorite word is of type string. And notice how I have the colon first right here, followed by the thing. This other time I have it the space, then the colon. This is again to denote the fact that the placement of the colon doesn't matter. I myself prefer to have it aligned generally with the type, but you can have it aligned either way. They're both valid. I can even have it in the blank in between. I myself prefer this where it has it favorite number is of type int, so I have that nice little reminder that it's the of type modifier for that. And to go inside this though, because I use the same variable name as favorite number, if I write favorite number, not favorite, favorite number equals favorite number is a let and a constant, and so I'm saving this thing is itself. Oh, that's useless. This is stupid. I can't do this. In order to talk to your internal state inside Swift, we have a keyword to do that, and the keyword to do so is self dot. And so self dot allows us to access the internal value, in this case the private data member favorite number, and assign to it the parameter favorite number into that associated value. So I'm taking the parameter favorite number and assigning that into the data member favorite number, just like we did in Java with our monster project. We're doing the same thing with Swift right here. In Java, we use the keyword this. In Swift, we're using the keyword self. So self dot is how I access the internal state of a Swift class. We'll do the same thing for the favorite word. So self dot and then favorite word. And so now I have two different constructors, or excuse me, inits, two different initializers for my Swift class, other class. I have the default init, which assigns the default value of int and string to the data members, favorite word and favorite string, or favorite word, I have the default init, which assigns to its data members of favorite number and favorite word the default values of int and string. I have the better init with two parameters, init with a favorite number and init with a favorite word, where it assigns to the data members the past values of the parameter using the self dot operator, and then the parameter we're talking to, assign it to the data member we're talking to, and assign it the value from the parameter. So let's demo that and see how it's going to work. So we're going to go right here and we're going to make another variable. So var and second class equals other class parens, and then var third sample equals other class, passing it the parameter favorite number, and then passing it a value that, comma, favorite word, colon, and then give it some string stuff. Yeah, stuff works. And in this case, we have two instances of other class now. So I have third sample and second class, those two different instances of the other class type. And here's where we're going to see what's inside other class. We have a way to actually examine the internal state in Swift using playgrounds. Over here on the right, we have the eyeball and we have the show result. The show result or rectangle allows us to look at the internal state right now of that object. And so I can look inside that, and so my favorite number, its value is 0. Because I use the default initializer, that goes up here and says favorite number equals int parens, which calls the default initializer for an int, which assigns a value of 0 to favorite number. The favorite word then has the default value of blank. Nothing in between the quotes, because the default value initializer of string is an empty string. If I look at the associated show results for the other class, we can see that that parameter of 876543 was passed to favorite number and is now assigned into that state, and its favorite word is stuff. So we can see the two different values that are going inside there. By changing the parameter of that, we can have access to the internal state because we use the self dot keyword. So self allows us to go in. The dot operator lets us go inside that object and talk to it. And then I assigned into it by using, of course, the assignment operator, aka the equal sign. So we're able to grab inside that. If I don't use a parameter, we have the default value that goes into those variables. So we have information that's automatically assigned to the object right away because we have one of two different initializers we can use. When we create an object, we have to use them. Now, to notice one of the differences that we have with Java. In Java, if I were to make a variable of that type, this is the Swift version. But if I were to go right here to make the same thing in Java, Java would be, have other class sample equals new other class, parens, semicolon. Notice that we have right here, we are missing the new keyword. In Swift, we do not use new to actually create an instance. So new object does not happen with a new keyword. We simply just call the init object. Also notice that I'm not calling otherClass.init. So I don't do otherClass.init. I simply do the name of the class followed by the parameters that it's required for whichever init we are calling. So I don't do .init. The .init is excluded from the call. If I actually try and do that right here, so let's try that right here as a sample. Actually, Command Z, let's leave that blank. Equals other class .init. You can write it like that. We look at our inspect element. It does it right there. But we don't explicitly have to use the words .init. That's like extra work. We simply just call the init implicitly by giving the name of the type followed by its parameter list. So the keyword init should only be used inside the class itself, not externally in a call. So it's a little bit different from what we're actually used to in Java. So Java it would have the constructor call because it's explicitly saying that name inside its the class header, where we'd have the constructor name right there, just like this. But in Swift, we just use the name of the class followed by the parameters. And so it's a little bit different from Java. We have to make sure we keep track of that. But just so you know, there's a way we have some way we're working with this. Okay? We want to also be able to see the example of change on state. And so we're not talking about the street. We're talking about state is the actual internal reference of that object. And so we're going to add a new method into our class of other class. I'm going to go right up here. And it's going to be a public method. It's going to be a func because it's a method. And we're going to do change internal status or internal state. Parens, no parameters. It's of type void. And generally, void methods always are responsible for changing state. That's what they do, is they change the state of something. They either change the state or they perform some process, which usually also changes state, unless it's printing, but that's different. And so what we're going to do in this change internal state is we are going to update the values of our existing data members. So I'm going to say self dot favorite number, and we'll say divide, or no, do times equals, and some nice randomy number, and self dot favorite word plus equals and more. And more. So I have a lovely method right here that's called change internal state. The change internal state takes no parameters, but affects the internal state of both data members to the class. And we're going to see what happens as we use that externally. So I'm going to go up here on my second class and say second class dot change internal state parens and third sample dot change internal state followed by parens. And so we can see right now our existing state on other class. The second class instance, favorite number is 0, favorite word is blank. When I call the method, though, on line 52 of change internal state, my favorite number is still 0 because times equals anything will always be 0. But notice that my favorite word now has and more and more. I'm able to access that internal data and change it from a publicly available method. So I can change internal data using state modifiers vis-a-vis a void method. If we look at the internal state on our third class, we now have our favorite number is ridiculously huge and stuff and more. So I have a definite change between my original sample of other class, which if I look at that state, so my original favorite number of 876,543 to be my new favorite number of 108,516,0234. Clearly a massive change in value. And then my original favorite word goes from stuff to be stuff and more. If I were to call that method again, third sample dot change internal state, I now have a ridiculously huge number and stuff and more. It's the best thing ever. And so we're able to see how that happens inside the class. This publicly available method changes the internal data because it can reference that data member inside itself. That private data is available, even though it's a public method, because it has that self modifier. It can go inside. It can talk to the private data because even though it's called publicly, it's using its internal reference to those variables. So we have some basic information there on that. That lovely square, that show results method, is going to be available to you as long as your code compiles. If your code does not compile, you have an error message. You want to make sure you watch for that. Just as an FYI, if you have any trouble, that's always the first thing to check. So again, just looking over what we just did, we have our notes today. We're using Swift to make classes and methods. We had our first sample. That first class right here, as soon as we add that line of var string, that we have to be able to have a init that initializes that. If we don't get it, Swift won't even compile for us. It's not going to work. We have to make sure we take care of that. We can access internal state by using the self dot, because self allows us to talk to the current object and go inside it. The dot operator is what goes inside the object. So self allows us to talk to itself. Dot then goes inside to affect the internal state. So I can affect that method. I could even call on here. I could call right here and I could say, oh, I could do an internal state called change internal state. If I do that, and I look at this, and I look at my second class internal state, because even though it's the first time I've called it, externally, that first call when I initialized it said and more. So now I have two and mores, because it's actually been called twice on that object. Probably not the best way to do that. But we can see some the way that Swift can do some of the basics right here, using the idea of visibility, using the idea of class names, using the idea of a method. And again, noting that inside Swift, we do not have the keyword new. We merely give the name of the class, followed by the correct parameter sequence we want to use. This sample has no calls, so it uses the default init. This sample right here has parameters, so it uses the parameter init specified right here with a favorite number and a favorite word. And so we have that basic structure. Aaron, question. So the question was, do I have to use self dot? And I don't. I can, and I find it actually usually most helpful to do so, just because it's easy to see that, oh, that's what I'm talking to. I didn't use it on that first init because it was just a continuation of what we were learning, and then I added it to that second one to show that just like, oh, I'm talking about that. And because you have to when you're assigning into a value. And so because there's no parameter on here that has the same name, I don't have to. If I had a parameter right here where it had a variable that was not favorite number, then I wouldn't have to use favorite number. And so, because I could just say equals this other parameter name. Save and commit. So again, going over to GitHub Desktop. Oh, we've got that lovely change to our contents.swift file. You can see I've got all that green code I've added. And so I just said demo with some sample classes. So I have a full-fledged commit message. I look at my history. I have a bunch of commits. If I want to see the value of these things externally, how do I have to make access to them? Since these are private data members, but I want to see them externally, what do I have to do? A little bit louder. I have to make a getter for it. And so I can go ahead and make a getter for that by doing public, and then func for the keyword, and then get the variable name, parens. It returns type int, followed by return, not return, return, and then the name of the variable again. And remember that everything we do in Swift, it always has the same basic approach. It always has a capitalized because all of our variables are all typed. And we don't use semicolons. I can make this better by writing self dot in front of it so I know I'm explicitly talking about the one that belongs to the class. So I have public func, and I have two getters now that go along with that. Getters work a lot like Java getters. It's the visibility, which a getter will always be public if we're writing one. The keyword func, because it's a method. The variable name that makes sense, followed by the return indicator, followed by the return type. And so I could do third sample, dot get favorite word, parens, and put that inside a print. Stuff and more and more and more. Now, if we have error messages, just a quick review. If I have a problem in something, like say for example right here, get favorite okay? My errors will show down here at the bottom in my compilation window. It'll give me information at the top of that screen. So what I want to do is I want to go down to that bottom window, scroll to the top of that bottom window, and read the first error first always. In this case, I have an error. Value of type other classes, no member, get favorites, okay? And it has the line where it has that sample is called. And so, did you mean get favorite word? Oh my gosh, that's so nice. Did you mean to actually use something? That's so sweet of them. Why, yes, I did. Let's fix that. I then print that, and it's right there. One other quick thing. Sometimes I don't want to see my results of my code. I can hide that. If I do Command, Shift, and the letter Y, my results window or results pane will disappear. Command, Shift, Y again. It'll pop up. So we added that method on there for the getters. That means I have a change I need to make. So added getters for the thing. Again, using full English sentence. Added getters for the data members.